Hello, welcome back to the Network Engineer Info intro video series on networking. Today we are talking about switching. If you haven't caught the last video was intro to routing. And what is a network was a video before that. And today again we're talking about switching. So we will get right into it. So switches operate at layer 2 of the OSI model. The layer 2 PDU, or protocol data unit, is the frame. So what's the basic purpose of a switch? So primarily the switch is going to switch frames. It's going to move an incoming frame to an outgoing port on the way into its destination, right? And how it figures out what path it should go on is something we'll kind of talk about here shortly. But its basic function is to switch frame. Or I should say its basic purpose is to switch frames. Now, a switch can have different functions in the network, especially depending on what type of location we're talking about. Small home office or campus LAN switches can have a few different roles and responsibilities versus a data center or a larger campus design. So in this conversation, we're speaking of switching more so in the access layer. And an access layer is a piece of the hierarchical design model, which has your core, distribution, and access layers in the network. And so we're specifically right now talking about the access layer because that's the most kind of, straightforward function that a switch can have. And in its role as an access layer switch, it's going to be the first device on the network that is terminating layer 1 connectivity so that host devices can have access to that network. Right, so we're providing that layer 1 connectivity from whatever that end host may be, which may be a PC, laptop, could be something that's providing additional network access, something like an access point, but it is making a layer 1 connection, whether that be through a copper, Ethernet, or fiber Ethernet connection to that switch. And more than likely that fiber Ethernet connection is going to uplink from your access switch to one of the other layers in that hierarchical model. And it could be connected to something like a router, but in most cases it's from an access layer, it's connected to another switch. So before we go into a little bit more about how traffic is kind of routed through a switched network, let's take a step back and talk about the data before it actually gets encapsulated into a frame. So the host communication or device communication, which is going to initiate propagating that frame across the network. You mentioned switches working in the layer 2 of the OSI model. And as data works its way down the OSI model, the last step before putting that data on the wire is to encapsulate your data into a frame. Again, that frame will have a source and destination MAC, with the latter pointing to the device on the local network that you're wanting to send data to. If that's external to the LAN, then it will that destination will be a firewall or a router. But the first device to get that frame on the network is generally going to be the switch, and generally going to be an access switch specifically. Again, that access switch is terminating your layer 1 of physical connectivity from devices on the network, and the switch will look at destination MAC address and determine how to forward that frame, accordingly to get to its destination. So we mentioned MAC address a couple times. So MAC address stands for Media Access Control, and we won't get into that specific meaning so much, but just know that the MAC address itself is a unique identifier for the piece of network equipment that is communicating on the network. So for your PC or laptop, it's going to be a NIC or your network interface card, and that network interface card is going to have a MAC address associated with it. Any layer 3 interface, so an interface that has an IP address associated with it, will have a MAC address for layer 2 communication. That MAC address is a 12-digit hex number, and the first 6 digits of that hex number is the OUI, or the originally unique identifier. The second 6 digits is the NIC identifier, which is that unique portion to each device. So the OUI is really going to is really assigned to the manufacturer of the NIC. So if Intel is making your NIC, the first 6 digits of that MAC address will identify who that vendor is, and then the last 6 will identify the actual NIC on the network as well. Because obviously you could have multiple NICs that are made by Intel, right? So that last piece is identifying the actual network component, and that's going to be unique to that machine. So you can get a look at what that looks like on your own machine. So if you have a PC, you can follow along here. You can open up command prompt and type in ipconfig/all, and that will give you your MAC address, and that's under the physical address label. So you see physical address, and then you'll see that 48-bit hex identifier, which is your MAC address. You can also issue the command, if you want to go straight to the MAC, you can on Windows, you can issue the command get MAC altogether, and that will just give you the MAC address for each of the network interfaces on your device. So we have some data, and it's worked its way down the OSI model, right, which is a representation of how data is communicated. And it worked its way down the OSI model. You've encapsulated that data into a frame, and now you want to send it to its recipient. And so you need to populate that destination MAC field in the frame. How do you get your destination MAC? Well, your machine's going to get the MAC via ARP, or Address Resolution Protocol. So presumably at this point you already have the IP address of your destination, and I'm going to send an ARP request as a broadcast in order to get the MAC address. And that broadcast is going to go out on the network, and it's going to query the machines on that network and say, all right, who has this IP address? And if you have the IP address, give me the MAC address associated with that, so I can forward this frame to you. Once you get an ARP response with the device responding that has that MAC or has that IP address, then you can insert that MAC into the frame and then put it on the wire. You have your frame, you have a destination MAC address, you send it on the wire. Now, how does the switch actually move that traffic around? So if the address is known in the MAC address table on the switch, and the switch has something called a CAM table, which is content addressable memory, which is basically a list of MAC addresses in the associated port. If that MAC address is known in the MAC address table, the frame is forwarded out the associated port in that table. When the switch receives a frame and it does not have an entry for it in the CAM table, it will flood that frame out of all interfaces except for the interface that it received the frame on. And it is flooding that out with the idea that it will basically acting like a hub at that point, assuming on a best effort basis that the frame will get to where it needs to be. The switch also does MAC learning. So when the communication comes back from the device to the originating device, it will come in on a specific port on that switch, and the MAC will store the port and the MAC address in the MAC address table, in that CAM table, and it will know from that point on where to forward that traffic if it receives another frame destined for that host. So the broadcast that you used during the ARP resolution is good for finding the device if it's on the local network. So if the the destination IP address is in the same subnet as your source IP, then you're on the same network. And ARP is a broadcast, so the broadcast is going to be the broadcast address of that local subnet. The broadcast domain will be encompassed in the current VLAN that you're on. However, if the IP is in a separate subnet, then the device will not be on your local network and will not be able to respond to the ARP request. And so in that event, since it's going to be on a separate network, it's going to be outside of your current network, the MAC address of your default gateway is going to be used, which in most cases is going to be a router or firewall, in some cases a layer 3 switch, but in either case you'll be sending that frame to your gateway, and it'll be using the MAC address of that gateway device in order to move your frame. So how does a frame navigate its way through a topology? Spanning tree in most cases is used, 802.1, IEEE 802.1D or 802.1W. Spanning tree or rapid spanning tree is used to create a loop-free topology within the switching environment. There's a placement of a root bridge within spanning tree, and that determines how your traffic routes through the layer 2 network. That is definitely kind of outside of the scope of this video, but I wanted to at least mention spanning tree because that somewhat determines what path your frame is going to take through the network, depending on how big your switching environment is. Okay, so we've gone over some high-level topics on switching. So let's talk about the switch itself and some of the attributes. So I have a little example switch here. This is a Cisco switch, and this is a 2960G, so bit of an older 8-port switch, but this is just a small kind of representation of some of the larger versions and something that I can easily fit in frame here. So yeah, this is an 8-port switch, and I actually, for those of you that are doing, studying for CCNA or whatever, you can pick these up off of eBay for pretty cheap. That's where I got this one. But there are certain, considerations, I guess, from a physical perspective when you're talking about switching and supporting, deploying, troubleshooting the actual switch hardware itself. So a couple things you have to think about with switching, with physical switches is, how you're going to mount this. A lot of times on the larger switches, they'll come with a rack kit, so you have rack ears, so you can rack it. Obviously, this is going to be too small for your standard rack, so the rack ears would have extensions out. But the 8 ports actually usually don't come with the rack ears. You have to order them separately. These are the ones from Cisco. So just something to keep in mind. How are you going to get this into a network rack if that's what you're using? Sometimes these actually just sit on top of a desk or on top of a tray in a rack. And these are small enough, but definitely on your larger switches, you'll have to think about that. Your power, how and where you're going to power up your device. Won't get into power too much in this video. I mentioned this is an 8-port switch, so port density is something you have to think about when you're speccing out switch, and then also how you're going to uplink. So how are you going to connect this to the upstream device, whether that be another switch or you're going to a router or a firewall. And many times you'll have specific ports that are designated for uplink. So this has the option. This is really one port designation here. So you have the option for using a copper connection, or you can insert an SFP here, small form factor pluggable GBIC that'll allow you to terminate either multi-mode or single mode fiber connection. You can also insert a Glick T here and do copper as well, but you have a static copper port here on the chassis. And then how you're going to access the device for initial configuration. So here on the front you have a console port. Generally you're going to be using that blue rollover cable and some type of USB extension or converter, so you can console into this using some type of terminal software. Generally on most modern PCs you don't have a serial port, so the console cable will need a converter in order for you to get access. But generally that initial configuration is going to come from that console port. There are some things you can do from an automation perspective to configure this, but in most cases, if you are a beginner, you will be, and even if you're not a beginner, you'll be configuring via console port. Generally, your interactions with switches are gonna be remote, right? I guess it's gonna really depend on your job function a little bit. So if you're, working for like a carrier or service provider, or maybe you're a consultant, it is, especially if you start out in those positions, it's conceivable that you don't actually get your hands in your day-to-day job on an actual switch. You're remotely administering the devices, and you don't really get your hands dirty. But then some other positions where you might be more of like an install tech, or you work in more of an enterprise position where you might be doing like installation, deployment of devices in an IDF or MDF. So in some cases you don't have to think about the list of things that I've talked about. Being able to rack your power, speccing port density, determining your uplink strategy, sourcing, buying SFPs, figuring out out-of-band access, initial device configuration. Sometimes you're just dealing with devices that are already in production, and you don't have to deal or think about those things because you're not deploying, or maybe another team actually does that. But in some cases you do. So I just wanted to kind of call those out. From an operational perspective, if you are supporting these devices, and you have to think about things like how you're going to monitor, which is generally done by SNMP, could be netconf, or it could be using telemetry, as well as syslog, and then iOS administration. So what kind of software you're going to have on these devices, your upgrade strategy when you need to upgrade code, all that good stuff, and then things like keeping track of LDOS or last day of support, end of life, how you're going to replace and update switches when they fall out of the support and support range from whoever your provider is, whether that be Cisco or another manufacturer. So those are all the topics I wanted to go over. So I just wanted to kind of introduce switching and some of the things you think about when supporting or deploying switches themselves. And that is our intro to switching. Again, this is a beginner series where I just wanted to get you exposed to some of these concepts, networks, routers, switches, and I'll be coming with some more content that gets a little bit more in depth as we go along. But thanks for joining me on this intro series from Network Engineer Info, and I'll be back with another video very soon.